The idea that it could hang together long enough to start attracting in other matter around it is just philosophically absurd. All right. So anybody who says that we could have a catastrophe at the LHC because we can make black holes there, they're missing a major point. They're missing a point that it's really only the very large black holes that you have to worry about sucking matter in. The very small ones, including the many, the jillions of them that were probably created at the birth of the Big Bang, were all evaporated away, so we don't have to worry about them nowadays. And that's what I think, if this theory is right, if this if this theory of large extra dimensions is right, and gravity is strong at these scales, and they do make black holes, I think there's absolutely no worry that they're going to suck matter in.
Okay, so let's suppose that there are extra dimensions that would allow us to create microscopic black holes in LHC collisions. That would be fantastic, by the way. It would be a really fun discovery. We would only discover it, however, if we could see them decay rapidly to lots of particles come spraying out in all directions.
You can think further. You can start then questioning, saying, well, maybe Hawking is not right, and maybe there are special black holes that don't evaporate, at least don't evaporate rapidly, and maybe they have time to move from one particle to the next, and maybe in the process of moving from one particle to the next, because of their strong gravity, they start swallowing one particle, one atom, then another atom, then another atom, and if they do this enough, you can start worrying, gee, they're starting to swallow a number, perhaps a large number of atoms along the way. Could that get out of hand?
Well, first of all, it would have to be that Stephen Hawking was wrong. And Stephen Hawking's work is based on fairly vanilla assumptions about how quantum mechanics works. There's no real reason to believe that that work is incorrect. But you never know, right? Science makes new discoveries all the time.
Yes, even if you want to be agnostic and question Hawking's evaporation, the process of production of black holes has been happening all around us, all around the universe, all around the Earth, quite frequently through cosmic rays. So the energies that the Large Hadron Collider will explore are already being explored in the universe all the time by very energetic cosmic rays colliding with other particles in the universe. For example, energetic cosmic rays have been impinging upon the Earth for billions of years. They've been colliding with particles in the atmosphere of the Earth at energies exceeding the LHC energies, yet no black hole has ever been produced throughout these billion years that caused any harmful effect. And the same has been happening not just on the Earth, but in all planets, around neutron stars, around stars, continuously everywhere in the universe, and it hasn't caused the destruction of the universe. So this is an empirical reason to argue that there is no dangerous processes that happen at high energies, at the LHC energies, that would cause the creation of a destructive black hole. And that is probably the most comforting argument, that we don't have to worry.
There are these high energy cosmic rays bombarding our atmosphere all the time, and they have such high energy. It's way higher energy than the collisions that we are going to create in the LHC. Furthermore,